Greetings, happy day.
Hola.
It is time for some energy transformation.
What?
My kids, aren't you glad you had me? That's so weird.
No, be excited.
Okay, here we go. 7 types of energy. That's it. 7 main types. Sometimes people say there's like 9, but they're weirdos. So try to brainstorm as many as you can think of in your paper before I tell you what they are. So you're brainstorming right now. What kind of energy do you think's out there, Grummy or Brookhart?
I don't know. There's a lot of different choices. I know you say there's only 7, but I think there's only 7. But the energy's just all around us, kind of like love. What? I'm a loving person. Sorry that
she is loving.
Miss Millis isn't.
Do you have anything down yet? You should have at least like 5 right now. Like think of the outside. When you go outside at recess, what do you see? Do you hear what I hear?
And I bet you know them. You just may not realize you know them.
Yeah, that's true. Okay.
The official names are
3, 2, 1. Bada bing. Grab yourself a ruler because rulers are cool, yo. Draw yourself this table. That is 1, 2, 3, 4, 5, 6, 7 rows, 2 columns. Sketch this sucker down. Pause the video.
And you're going to want to make sure that you leave yourself a couple rows in each row of your table, because you're going to need to write descriptions for each energy type.
This is probably about 3 lines each. Now pause the video. Make your table. Come back to us in a minute. We don't have to pause.
No. I was like, I think we keep going.
We can keep on going. Oh, you love us. Okay, so we can read these out to you. Mechanical energy, heat energy, light, sound, electrical, chemical, and nuclear. Mechanical energy. Okay, so this is, oh good, I'm writing. The energy of motion. Should we give them an example?
Yeah, let's give them an example.
What are you thinking, Remy?
I'm thinking about like whenever I catch you secretly dancing in your room by yourself. That is mechanical energy. All those movements you're doing, yeah, that's mechanical energy.
Yeah, but I'm not a machine. So living things can have mechanical energy.
Yes, absolutely.
Even though it says mechanical, but also so can like a fan. A fan moves. Oops, there's my S. It's a Friday for us. I don't know what day it is for you. It's a Friday. You can tell.
A Friday on a 3-day weekend.
Sweet. Wah, wah. So there's 2 examples. So living things can move, and so can non-living thingamajigs. Okay, heat energy.
Heat energy is pretty much like what it sounds. Energy can be transformed to heat energy when objects are giving off heat. So once again, living things give off heat, so you are giving off heat energy right now, right?
I am.
Okay, well that's good because you're still alive.
Woo. For today.
And then a lot of machines give off heat energy too. If you ever notice, like the laptops that you use here at school, once you can feel them actually heat up. If you touch the hood of a car, as soon as it's turned off, you'll notice that it's warm from running, even in the winter when it's cold outside. So those are some examples of heat energy for you. So basically what we're saying is Miss Millis and I, we are hot all the time.
Another word to call this is thermal. Think of your thermal underwear. Thermal underwear keeps you warm. Thermal energy does too. And we'll learn more about this. But I'm going to sneak in a new word. The heat energy is coming from infrared waves. So we're going to hit that in about 2 months probably. Oh, maybe less than that. Month and a half. So infrared waves is where the energy comes from. The reason we didn't throw that in the definition is because you don't know it yet. But it's a sneak peek. Woo! Look at that spoiler alert.
Bum, bum, bum.
Okay, light energy. So that is like the energy that is transferred through light waves. That is, this is hard to write. Transferred, is that 2 R's?
Mm-hmm.
Oh, I put one. Through light waves. Okay. Light waves has a fancy name. Should we tell them it?
I don't know. You think they can handle it?
I think so.
All right, give it to them.
Electromagnetic waves. So that's light energy. And light has energy. Do you know how we have proof? Hello?
Oh, I do.
Oh, what were you going to say?
I was gonna say the sun, solar panels.
Ooh, and the sun. The sun is a massive incandescent gas. Liars. It's not. But the sun has energy, which is why it grows our lovely flowers. See?
And Miss Mills, did you actually know that we have solar panels on the top of our school?
No
Here?
way. What was that?
Yeah, and we have this thing called the solar tracker. We can maybe show kids one day that shows how much energy our solar panels are actually producing for us.
We should do that. There's that thingamajig by the 8th grade lab. There's a computer monitor there, and you can see it.
Oh, okay.
Nice. Okay, so light energy, electromagnetic waves. So you can call it like electromagnetic radiation even. Energy is transferred through light waves. Okay, 4 more, and we are good to go. So these definitions are not complex. We're not going all scientific on you. It is very basic. I don't know why that box is blue, but it is. So this is the energy transferred through sound waves.
And it is exactly what it sounds like.
2 R's, right?
Yep.
Transferred.
Sound. So you talking, us talking right now, every time you sing in the shower, you're producing sound waves. The honk of a horn, sound waves. Okay, sound energy.
So, example, shower, singing, even the shower water, and, oh, honk. Goose honks or car, both consider sound waves. There is no fancy name for sound. Oh, poor sound. I wonder if he feels left out.
Probably.
So, guess what? Do you see a pattern here for definitions?
Yeah. 2 common words. Get used to it.
So, electrical energy is transferred through electricity. Those itty bitty electrons, despite the fact that their size, they have tremendous energy. Just think, when you get electrocuted, those electrons are what does the deed.
Yep.
Don't stick a fork in the outlet.
Yeah, so electrical energy can be kind of the more common things, like anytime we turn on a light, there's going to be some electrical energy, or it can also be through natural phenomena like lightning.
Phenomenon. Look at her using big words.
What?
I don't have yellow, guys, so you're going to have a green light bulb. And lightning.
That's a great way to drawing.
Thanks.
Okay.
My pencil and fat dollars, which is a little thinner. I don't know how to change that setting. Okay, so that's electrical energy. But, so this is like static electricity. Remember you just studied that, static electricity. So it does consider electrical energy, and you have light. And even there's electrical energy in your heart, which is why you've seen on the shows, clear! When the heart beats, is electrical pulse that makes your heart beat, which is super cool. So like those heart cells will beat by themselves even. They have that electrical pulse. And when you put 2 of them together, they like sync up.
That's pretty cool.
Yeah, it's really cool. We should go dissect a heart sometime.
Oh, okay. Don't use mine.
Plan B. Okay, so this one here is more of a stored energy.
Yeah, that's a good way to put it. I like that.
Stored energy in chemicals.
So a really good example of this that you guys use regularly is batteries. Batteries have chemical energy in it, so it's stored. It's not being used all the time until the device is actually turned on. What's another?
Twinkies.
Twinkies have chemical energy?
Yeah. When you eat a Twinkie,
Oh,
and a scrumptious goodness,
I
it
see what
all
you're saying.
digests and sits here, and then your stomach like takes away all the good stuff, all the chemicals to use it for.
And fireworks too, don't they?
Ooh, fireworks. Maybe I'll just draw fireworks. Let's see.
Okay. Maybe add some other colors in there for us.
I'm sorry, I only have 4 choices, friend. So there's the firework thingy. It's like, it will have. Yay, 4th of July.
I complimented you on your light bulb. I don't know that I can do that for your firework.
Not see you working here. Okay, nuclear energy. Ooh, this is the toughest definition. What should we say?
Well, I mean, let's start with our classic.
The energy
Mm-hmm.
found. It's more of a it's more stored in the nucleus of an atom. Atom, nice. It's the nucleus of the atom, and then when that nucleus, man, gosh, that thing is so small, and when that nucleus gets disrupted, like it gets cut in half, then you have a gigantic bomb, which is amazing that can even happen because the nucleus is like tiny. Can't even see it with a microscope. So it takes like a tremendous force to hold the protons and neutrons together, and so when it gets disrupted, bam, and that's where you have the atomic bomb.
Yeah, so history lesson, U.S. has only used 2 atomic bombs in our entire history. Hiroshima and Nagasaki,
Oh yeah, I think so.
is that right?
Hiroshima was the one in Wolverine.
Yes. And then also, maybe you have seen them or heard of them, nuclear power plants. This is another place that we have some nuclear energy
Homer
going on.
Simpson works at one.
Yes.
So yeah, nuclear power plants. I don't think we do have one in Missouri, right? In Fulton?
Yeah, we do in Fulton.
Okay.
In Fulton we have one.
But most of our power does not come there. We use coal, but in coal, that was a good one here. Coal for power.
Ooh, yeah, that's
and
good.
gasoline.
Mm-hmm.
That would be a good chemical energy. But some we do have nuclear power plants, but they're mostly are they on the coast east?
Yeah,
But they're I mean they
because
come
they need to be by water.
and they had good
generally.
and bad because remember Chernobyl,
Yep.
is that how you say it? Chernobyl
Mm-hmm.
in Russia.
Yep.
Or SSR. No, it is Russia. Don't talk to Wallace about this. I don't know my history very well. But Chernobyl had some issues. Meltdown.
Yeah. Yeah.
One of the thingies.
Yeah, it leaks.
It leaked.
And
Yeah, which is devastating because once that stuff comes out in the community and people like getting in your blood and getting your system, things happen.
Yeah.
People die, cancer. It's not good at all. So, but it's a clean energy. But when accidents happen, it's a big accident.
yeah, and it's really bad for like soil and the plant life and stuff
That's
around it too. So
And the atomic bomb, if you saw Wolverine this summer, I mean, you saw the A bomb go off in Japan, and you only saw tidbits of it because they were hiding in that thingamajig, that little well thing, that prison, and but it devastated life all around. So atomic energy is gigantic. Yeah, we're videoing. We'll come back.
can we come to you in a second? You got this?
I got this.
Okay.
Okay. So energy cannot be created or destroyed. Really weird to think because like I put batteries in and like those batteries had to be made somewhere, right? So when I'm running out of batteries on my remotes, I like just put new batteries in and I buy them from Energizer and Energizer made the battery. But really when they make the battery, they get their energy from those chemicals, which then they got the energy from somewhere else. All the energy that ever is and ever will be has already been created. So we don't make energy, just like last year we learned we don't make matter. There's like law of conservation of that matter, and you can't make matter, it just changes forms. So energy cannot be made, nor can it be destroyed. So when that atomic bomb goes off, we are creating light energy and heat energy and thermal energy and chemical energy. So we are just changing it from one form to another, which I just messed over here. So energy is transformed from one type to another. So the word transformed, it means changes. Right?
Yeah.
Yeah. So Hulk changes from Bruce Banner to the Hulk. It's not a new person, it's just changing from one form to another. And that's exactly what happens to energy.
Mm-hmm.
So we're going to practice this here, and then I'm going to show you a video. So here's 2 things that you find around your house. If you go into your parents' garage or basement, you might find a drill. Let's pretend that thing is plugged into something. And there's a couple types of energy. It starts with, up here it says electrical energy. So those little bitty electrons are having fun. They're going, woohoo, trip down the wire. But when they get to the drill, you know.
Ooh. Well, you have sound energy because.
Which one's that? Yeah, there it
Oh,
is.
sorry. You got sound energy because it makes a noise.
Yeah, you can't drill in secret. People hear it.
And the whole point of a drill is to put a screw into something or drill a hole so you got mechanical energy.
And that sucker right here, ouch. Don't touch it. Stuff that gets hot. Heat is a side effect energy on many things. Like really, the purpose of the drill, the sole purpose is to put that screw into the wall or whatever. The sound and heat are kind of wasted energy. They're not necessary at all. So those are just byproducts, but they are produced. Let's look at this really old computer from like back in the day. Gosh, you probably have never seen a computer like that, guys. So the main function would be, not that, oh, sound could be the main function.
If you're listening to music on it, okay.
Is this, nope, that's the one I wanted. Light to see the screen.
Yep.
But there is the side effect of heat, once again. But technically, and I know some of you guys are out there saying, whatever, Millis, there's also mechanical. Because inside of it, there's thingies that move. You're right, there are thingies that move. I don't know what those thingies are called, but there's thingies in there that move. Like gears in the CD-ROM or DVD player.
Well, and when you type on the keyboard too,
Yeah.
you're moving the keys are moving.
So there is some of that. But the main focus for this one is the sound and the light. Heat, again, is a byproduct of that. Now, I want to point out something like those light bulbs they have nowadays. I mean, for you guys, it's been out for most of your life. When I was a kid, every light bulb looked like this. Nowadays, light bulbs are called CFL, and they look like that. These guys produce light and heat. 90% heat, 10% light. A light bulb's not used to heat up my house. Yours?
No.
No. Yeah, it's used to light up, but 90% of the electricity gets converted to heat. Complete wasting energy. So that's why
It went to a more energy efficient bulb, is what they call it. Do you know the percentages on that one?
I don't know the percentage. I always have to look up.
Either.
But I believe it's I think it's in the 90s. I think it's the upper 90s light, and it's very minimal waste with heat. So really, when those are on for a while, they don't get so hot, and you can kind of touch them still. But these, there's no way you can touch them.
Nope.
Okay, so that's it for this. I want you guys to watch this video, and I'm going to change my screen, so it's going to kind of be annoying. Oh, there's my background. Okay, so here's a video of The Dark Knight Rises. It's the movie trailer. And I want you to list as many energy transformations as possible. And you won't miss it. You won't hit them all, but try to hit several.
And if you need to pause it while it's going to catch up, feel free.
I'm going to unplug this.
You are as precious to me as you were to your own mother and father. I swore to them that I would protect you, and I haven't. The bear's with them, Spring. Really. He's a hero, a war hero. This is peacetime. We thought this could last. The storm coming this way. You and your friends better batten down the hatches. It's what it is. You often wonder how you ever thought you could live so large and leave so little for the rest of us. What does that mean? Rise.
Should I?
Wake off your nerve. Ashes. You have my permission to die.
I like this chance one.
I like these movies.
We like the Harry movies. It's super interesting. Superhero. Okay, it's a good movie, but it is rated R, so do not go see it without parental permission. Any other thoughts, Miss Grummy? Part?
No. I mean, hope you enjoyed the video. Glad you guys still think I'm cooler than Miss Millis, and
So cool.
we'll be back later.
See ya. Wouldn't want to be ya. That was longer.
Yeah, I'm not
But-
really doing that though.
But that was a 2-minute video at the end. So, okay. I just don't know where I'm going to put these yet. I haven't put them on YouTube because Kathleen says that not all the videos are